Welcome to review number 2 for test number 2 in regards to pre-cal. Now, one of the things I want you to do before we even start me showing some examples, I want to go ahead and let you know there's 3 things I want you to do with this video. The 3 things I want you to do is after when you're watching this, you got to constantly self-evaluate yourself. You want to make sure you remember, and the only way you could do this, you need these things as a minimum. Remember, understand, and apply. Now, if you watch this video and do not go back and see if you can remember, understand, and apply, you're really doing no good to yourself. If you would just watch the video and look at the stuff, and just watch it, kind of like when you watch a TV show, you're not going to be able to recall everything. What you need to do in order to take the full use of this video is go ahead and look at the problems, and then go ahead and cover up your answer, cover up the video, pause it, get a separate piece of paper out, try it, and see if you could do it on your own. If you just watch it and don't see if you can remember, understand, apply, you're going to look at the test and say, hey, you know what, I don't really remember how to do this. There's really no learning that has occurred. So to get the maximum use of this video, please do those steps. Now let's go ahead and begin with question 1. Now my numbering on mine will be different from yours. So you will, but in the essence, we're going to go through the same problems. Let's go ahead and start with the first one. Now the first one, they're saying write a function whose graph is the graph y equals square root of x, but is shifted 5 units down and compressed vertically by a factor of 3. Now a couple of things we got to do. Let's write the general form of the equation. Y is equal to a cx minus h plus k. Now remember the k deals with vertical movement up and down. This one deals with horizontal movement. This is vertical stretching or compressing. So this is a vertical stretch or compress, and this is a horizontal stretch or compress. Now the reason why I bring this up is because when we are looking at this and they're asking, there are a couple of things that they want to do. You wanted to shift it 5 units down. So automatically I'm going to have to use k. So we're going to go ahead and use k here, square root of x minus 5. This shifts it 5 units down. And they want a compression of vertically by a factor of 3. Now to compress vertically, that is the a, and what we're going to do here is a fraction. This compresses. When you have fractions, it compresses. When you have anything bigger than 1, it stretches. So in this case, in order to have a vertical compression, we have to apply a third. So here's our equation, and that will be our answer. So you just got to go ahead and, now if they would have said vertically stretched by a factor of 3, then the a would have been 3. But in this case, since they're looking for a compression, then we will go ahead and apply the correct one, which would be this one. Okay, lovely. Let's go ahead and move on to number 2. Number 2 talks about name the parent function associated with the following function. So first of all, when you see this function, it's going to look like a V somehow. I'm not graphing it, but knowing that I have absolute value signs means that the parent function automatically will be y equal to the absolute value of x. So we're going to have that as a parent function. And then it says describe each transformation to make the parent function of the graph of the equation. All right, a couple of things are happening here. First of all, remember we said that using the general form of the equation, y is equal to a cx minus h plus k. I have, first thing I'm going to start with is with this k, and this is going to shift it 5 units down. Five units down, lovely. Now the second thing I'm going to go ahead and now write down is the h value, which is very important. Now this one does opposite of what you see. So with this one, it's going to shift to the left. So it's going to go in the other direction. Shift to the left horizontally. I have to also describe the direction horizontally. Shift 5 units down. I guess you could call it shift left horizontally by 2 units. or you can say 2 units shift to the left. And the last part, well, a couple of things. We also have we have an a value, which is here. Now, the negative the negative in front of the half is gonna make it reflect on the, so it's gonna reflect on the x-axis. So you got to make sure that you understand that the negative a reflects on the x-axis. And the last part of this is a half, so we're going to also have a compression. It's going to be compressed by a factor of 2. So that's our compression by a factor of 2. All right, lovely. Let's go ahead and now move on to the next one. And this next one, they want us to go ahead and do something similar as far as state the parent function. Now, when I see the square right here, the degree will often describe what kind of parent function it is. So like in this case, it will be y equals x squared. This is going to form a parabola. Now, two things are happening in this one. First of all, it's going to shift, and let's read the directions first of all. Most important part of any exam, homework or anything, is always read the directions. Graph each of the following functions using the techniques of shifting, compressing, stretching, and reflecting. Start by graphing the parent function, explain the transformation each to create the new graph. So first of all, let's do the parent function. Here, 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 here. So our parent function is going to look like this. All right. Now, transformations are going to occur to this function. First of all, we're going to go ahead and it's going to shift. I'm going to go ahead and make sure I do this in a. So it's going to shift to the left. Shift to the left by 1 unit. So 1 unit shift to the left. So we're going to shift to the left by 1 unit. So our vertex is going to start here. Actually, no. That is actually incorrect. It's always opposite of what you see. So it's going to shift to the right. So go ahead and make that correction. Remember, we have to be careful when we see those. So I'm glad I brought that up, because if you're thinking the same thing I was thinking, then you got to make sure that that keeps as something as a standout point, as a memory point, that it's going to be opposite wherever you see the H. So we're going to shift over. Now the other thing that's going to happen is that this one's going to go ahead and be stretched vertically. Stretch vertically by a factor of 2. So when it stretches vertically by a factor of 2, that means that all these points, typically this one is going to be now here. Okay, let me go ahead and show you that. Here, here. And instead of having 4, we're going to have 8. It's virtually all my x points that I would have had before. Instead of 4, they're virtually doubling. So we have, and you also could graph and you'll see the same exact thing that's happening here. Now with this one's similar to the last one, and we had an absolute values of parent function because of the absolute value signs. So in this case, the parent function will look like this, and where we have 2 vertical lines that look like a V, but with the idea that they're both positive. So now a couple of transformations with this one. First of all, the K value. So it's going to shift up 4 units. Shift up 4 units. And it's going to shift to the left 3 units. So this origin that was here is really going to shift up 4 units and over to the left by 3. Remember, it always goes opposite. I'm going to have that here. Now, the other thing that's going to occur is the fact that we're going to reflect. First of all, you all see the A value? This negative in the A value means we're going to reflect. Let me pause this for a second. All right, let's go ahead and continue with this now. So with this one, we're going to be reflecting across the x-axis. So, and this happens because of that negative I just pointed out. Reflect across the x-axis. So we're going to now change all our points. Now we're going to also, the A is being compressed by a factor of 3. 3. Now, to best illustrate that, let me go ahead and see if I could, let me bring up my calculator, see if I could just graph this for you. And then you'll see the occurrence that we're having with this one. But what's going to happen in essence, while that's coming up, is that this is going to shift down. So like instead of being normally at the regular point 1, it's going to now have a 1/3 shift to it. Here we go. And I'll show you to verify what I'm talking about. Y is equal to, clear this. Let's type in -1 divided by 3. And we're going to bring up the absolute value sign now. Now you hit the absolute value sign by hitting the second 0 button, and the ABS will bring up that value. We're going to put our x plus 2 in there. We're going to come on the outside because we have to put +4. And when I hit graph, you're going to notice this V now that looks what we call being compressed. So the points on it, actually, typically I would normally have a point at, let me go over here where the shift happens. Let's see, -5.3. Yeah, no. I think it's -5. No, actually, -2.4. And if you notice, it's going to be 3 points before I hit a whole one again. 1.3. Because this is what is happening on this graph. On this graph, in essence, we're going to now have the idea that this is going to be compressed. So instead of normally putting a point here and take away that point, it's going to be now 1/3 to get to it. Actually, let me make that in red as well. So 1/3 there, 1/3 here. So this is virtually going to make something that looks like this. Okay, lovely. Let's go ahead and move on to the next one. And the next one involves compositions. So first of all, they want to know the domain of the composition of both things. Now, first of all, before we even start, remember these things follow grandfather clauses, which means that what you're going to have to do is you have to automatically go ahead and actually find the domain. Domain of this one is all real numbers. Domain of this one is all real numbers x, such that x cannot equal 2. Now, if you ever have trouble defining this, you should always take your denominator, because that's the only time it occurs. If you notice, this denominator over here is 1. So, but over here, there is an x, a variable in the denominator. Variable in denominator. And when that happens, when you have a variable in denominator, you need to look for an error. Need to look for an error. Okay, so now with that defined, you just set it equal to 0. It's at 2, the error. And that's how I went ahead and found that. All right, so now with that all made out, let's go ahead and actually do the composition with it. Now the composition means that we're going to go ahead and, like the fog. So now the important thing of what I just wrote up there, of this part, is that this automatically is going to be down here in the domain. We're going to substitute now g of x inside f of x, which means in essence we're going to take this whole equation and place it right in there. And so let me go ahead and do that and write it down so you'll see it. 3 times 5x minus 2 plus 4. All I have to do is cross multiply there. I'll get 15x minus 2 plus 4. I have to get one common, when you have two fractions like this with the variable in the denominator, we have to get one common denominator. Currently this is 1, so it's missing the x minus 2 in order for me to get a common denominator. Now once I get the common denominator, I could place it under one whole one like this. And I'm going to go ahead and distribute that 4. So I have 15 plus 4x minus 8. After that, these two terms combine. So I really have 4x plus 7, x minus 2. There's not, so the composition is going to be 4x plus 7, x minus 2. There's no new domain. The domain is the same one we had before. So our domain is going to be x is all real numbers such that x cannot equal 2. Now let's go ahead and now do the GOF, which is the other way around. And with the GOF, we're going to do the exact opposite, where we're going to take the f of x and place it inside the g spot. So we're going to place the, virtually going to do this, and I'll put it in here. So let's let me take that away. Oops. I'm going to take that away so I can see that better. And all I'm going to do is 5, and then I'm going to have 3x plus 4 minus 2. Now this is a parentheses there, but since there's nothing around there, I'm just going to go ahead and not write it in. And I'll end up with this 5 over 3x plus 2. Now this one was fairly simple to compose and to get a solution. No common denominator on this one. But what we did have is a new domain. Now to find out what the new domain, because you see how we said we have a variable in the x, we have to set it equal to 0. Subtract 2, subtract 2. These cancel. You'll have 3x is equal to negative 2 divided by 3, divided by 3. This is going to be my new domain restriction. So two things we got to do. Write down our original domain restriction and then add this new one, 2/3, negative 2/3. And now we have a full answer here. Now let's go ahead and now work on number 8. They will still want us to compose the function. So with number 8, let's do the same thing. Before we start, you have to find domains. Now with this one right here, there's something special with the square root. When you see a square root, all the numbers need to be positive. To be positive. Now this is important. Now the reason why this is important is because anything that falls inside the radical needs to fall under an inequality that is stating that's going to be greater than 0. So when I add 1 to both sides, I find out that x has to be greater than or equal to 1. So automatically this domain right here is going to be x such that, actually, let me do some erasing here. So I could go ahead and write this down for you. X domain is x such that x is greater than or equal to 1. So we have this as a first domain restriction. Now over here, as you notice, there's no square root, there's no denominator, a variable in the denominator, so this one domain is just going to be all real numbers. So that one is fairly simple. Now let's actually do the composition. Now the composition with this one, it's going to be kind of exciting because we're going to go ahead and substitute this in here. So we're going to actually do the FOG first. The FOG of f of g of x is going to be then, means that we're going to take this and put it right in there. So we're going to have one radical, x squared plus 3 minus 1. So when I do this composition, I'll have x squared plus 2 when I simplify. And we will have actually a new type of domain restriction that occurs as well with this one. Because once we do the substitution, we're going to have to still have where x squared is greater than or equal, oops, let me go ahead, what we just said before, whatever falls in the radical still needs to be positive. So in this case, we're going to go ahead and now do this. We're going to, but in this case, you know what, since we have a square, there's something special that occurs here. And I'll tell you right now, if you put any negative value in there, any x negative value, it's going to automatically make it until positive. So this one is going to still, this one actually is going to be all real numbers. I think if you try to do what we were talking before of setting equal to 0, you'll get an error, and I'll tell you why. I mean, take the square root here, because in this case, there is no location where that is going to be an error at. So in our case, this is going to still be all real numbers right here. Okay, we'll have this as being all real numbers, which means that for this one, the composition would just be that, and our domain restriction would just be our original one, which is going to be x such that x is greater than or equal to 1. So we have that part. Now let's go ahead and continue the other way around. Let's do the g of f of x. And the g of f of x means that we're going to do the opposite of what we're doing here. We're going to go ahead and take this. Let's see. We're going to now take, oh, actually, we really don't need to erase that. What I want to erase is just this part right here. Because we're going to do the opposite. We're now going to take this amount here and place it right in there. So with in mind, it's going to look like this. Square root of x minus 1 squared plus 3. The squares cancel out on it. We'll have x minus 1 plus 3. And our answer will be x plus 2. So there's really not a new domain restriction with this one. We just have to grandfather our old one that we had originally for our original equation. So we have this one in essence. Okay, excellent. Now with these right here, they want to determine the functions one-to-one. They also want to, hold on a second, let me go ahead and do this. I'm going to pause it here. All right, excellent. It looks like we left off right at this section that we talked about how to find one-to-ones, find its inverse, state the domain, and find its range using the inverse of the other one. So let's go ahead and determine the function of this one. Now, how do we tell if something's a one-to-one? We have to graph it, and then once you graph it, you have to go ahead and look at the graph and pass two tests. First test is a horizontal line test, and the one you're very familiar with is the vertical line test. If for some reason it fails either one, you do not have a one-to-one function. Now, you have to be a bit careful, because like this one right here, let's go ahead and graph it so you can see how it looks like. Y is equal to x squared plus 16. At first likes, well, actually it doesn't show up because they put plus 16, so we have to change our window. Let's change it to 0 to 20. I hit graph, and you'll see it shows up. At first likes, you may say, oh, it does not pass the horizontal line test. It has a domain restriction, and I'll place it in here so you can see what it does. Domain restriction is that it's all the values less than 0. So I'm going to hit divide, go hit second test, and go into my logic menu. Okay, I need to put x first. So first, second test, logic menu, 0, and now I'm going to get a graph and where all the values are less than x. This right here will go ahead and actually pass the vertical and horizontal line test. So this one right here will actually be one-to-one. So yes, determine the function. So this one you can say it's one-to-one. Yes. And then from here we have to find its inverse. So state its domain and find the inverse. So domain will be x such that x is going to be all real numbers. So I'm putting this down. X is just an element of all real numbers, which is in essence just meaning that I have all real numbers. Now let's find its inverse. First step is change y in the place of f of x, and then switch the positions of x and y. So x is equal to y squared plus 16, and then solve for x. So negative 16, negative 16. We'll get x is negative 16 equal to y squared. I'll take the square root of it. I'll just put the correct notation of the inverse of s is the square root of x minus 16. Now when I find the domain of this, a square root has a special property in that whatever is inside has to be greater or equal to 0. So when I add 16 to both sides, I'll find out that x is greater or equal to 16. So like in this right here, the domain restricts x is greater or equal to 16. Now we have a property that states that the inverse, the function and its inverse have the special quality that its domain is the range of one and the range is the domain of the other. Which means that we're going to use this to our advantage to state that the range for original function is y such that y is greater than or equal to 16. All I did is change the x's to y's, but that's the range of this current function here. So we have that as a solution. Now let's go ahead and do the next one. The next one, this is a linear line, and this linear line, when you graph it, y equals, let's type in 3x minus 2, and clear everything else out, 3x minus 2. You'll find out that this linear line actually will be one-to-one. Why? Because it passes a horizontal and vertical line test. So one-to-one, yes. 1-to-1, yes. And then so now let's go ahead and do this. Let's switch, let's go, while the domain of the function is just all real numbers. Now we're going to do the inverse part, so I'm going to switch, do our steps, changing y to, from f of x to y. And then x is equal to 3y minus 2. We switch positions of x and y, and then we can solve for y. So that means I add 2, x plus 2 is equal to 3y, divide by 3, divide by 3. Y is equal to x plus 2 over 3. And then after that, we go ahead and we separate this because I just want it in the slope-intercept form. Now with this one, the domain of this is all real numbers too, which means we're going to use the same properties to state that the range is all real numbers. So this combined with your inverse function combined with this are the 3 steps to go ahead and get the solution for this one. Now I went ahead and worked 11 in class, so we're going to skip over this one for the sake of time and move on to the other ones. Now this one I also went ahead and worked this in class as well. I didn't do the g of f of x, but I'll go ahead and do that now. Now the g of f of x means that I will go ahead and take this or this and put it right in that little x spot. It's going to have this form, 3x cubed minus 8 plus 8. Now you could put parentheses here if you want to accentuate the fact that we have a how do you call it, a substitution, but there's nothing around there, so you could just take it out. After that, we left 3x cubed. This and this cancel out, so you just be left with x. Now, the other one also leaves you with an x, so you go ahead and do that. I want to go ahead and focus on number 13. Now, number 13 has us doing the same thing. We're going to do f of g of x, and we're going to see if that's an inverse, first of all. So the first thing I'm going to do is I'm going to go ahead and substitute this equation into the 2 x spots. So 2, 4x minus 3, 2 minus x plus 3, and then also down over here, which is going to be 4x minus 3, 2 minus x, plus 4. Now, we're going to have to distribute this too, and I'll end up with 8x minus 6 over 2 minus x plus 3. And then over here, I'm going to end up with 4x minus 3. I'm just carrying everything over, 2 minus x plus 4. Now I have 2 fractions. My first step is to simplify and get one single fraction for a numerator and a denominator in order for me to apply more algebraic properties. So there's a 1 underneath here, so you got 2 minus x, 2 minus x. I'll end up with solution 2 minus x, and then I'll distribute this 2. I've got 8x minus 6 plus 6 minus 3x. Now as far as the denominator, 2 minus x, 2 minus x, so I'll have 2 minus x here. I'll carry the 4x minus 3. I'll distribute the 4 and this, so I'll get 8 minus 4x. And when I simplify this, I'll get that these will cancel out. I'll be left with 5x over 2 minus x. And then over here, these will cancel out, and I'll be left with 5 over 2 minus x. So what's going to occur here is that we'll have the last step, I have to multiply by the reciprocal here. So 5x, I take the numerator, multiply with the reciprocal of the denominator, and these will cancel, I'll be left with x. So that proves the first half of the equation. It is true, it does work, it is part of an inverse. Let's go ahead and extend it over to the second half. Let's see what we get. So now we're going to do the opposite of what is shown here. Now what I'm going to do, and let me go ahead and erase this. At least I want to get half of this screen to do this next transition, which means we're going to do the g of f of x, which means we're going to put everything inside the other one. So now in this case, we'll have 4 times 2x plus 3 over x plus 4 plus 3 all over 4x minus 3, 2 minus x plus 4. And so we'll have, let's see if I did that right. Yes, I did. Well, should know. I did the top part, the bottom part did not. I looked at we're going to be now putting this in there. So we'll have 2 minus 2x plus 3 all over x plus 4. So let's go ahead and continue our solving process. We'll distribute this first, which means that we'll distribute that and that. So we'll have 8x plus 12 over x plus 4 plus 3. And then we'll have, so over 1 we'll have x plus 4, x plus 4 minus 2x plus 3 over 4. And I'll go ahead and distribute the same thing here. X plus 4, because I want to get a common denominator in the numerator and the denominator in order to be able to get the next part of my solution. X plus 4. Distribute this up here, so I'll have 8x plus 12 plus 3x plus 12. And then over here, I'll have the ability to do x plus 4, a single denominator. I'll carry this. It's going to be 2 times each one of these, so I'll have 2x plus 8. And then this negative needs to be distributed to both of this. So minus 2x minus 3. All right, so let's go ahead and continue. I'll continue this way. Now these, those are going to add, and these are going to add. So I'm going to have 11x plus 24 over x plus 4. And the denominator, I'll have, these will cancel out. I should be left with 5x plus 4. So that leaves us with something very interesting here. And then when I multiply by the reciprocal of the denominator, 11x plus 24, and just let me make sure I did all the math right up on top. I say the substitution, I substitute the right values, 2x plus 3, x plus 4, plus 3, 2 minus x, yes, that's all right, that's all right. So what is happening is with this one, when I do my last step and I multiply by x plus 4 over 5, oops, x, actually, this should be 4, not 5, there should be 4. When I do my last step, I'll find out that when I do the GOF, I'm not left with an x. I'm left with 11x plus 24 over 5, which means that not inverses. All right, excellent. All right, listen, go ahead and take some time to go back. Remember, it doesn't do much good just to watch it and not practice any of this. And what I mean is that write some of the problems down again. See if you could do it yourself. And if you're able to remember, understand, and apply without looking at any of your notes, then you're ready for this exam. Thank you for watching this.